Welcome, everybody. This is part two of Module 2 lecture materials. My intent here is to kind of reinforce some of the topics that we talked about last week, and also to introduce you to a new concept. And it's not a new concept, it's new to us. Uh, Basically, an alternate way to do if statements, which is very powerful, which is called the switch case statement. You can see right now I'm in the study materials entry of module 2. We did go through the slide deck in its entirety last time, and got through all the materials, which is pretty good. I don't always manage to do that in one night. Sometimes I do, sometimes I don't. But I did want to talk about the other resources that we have here and how these may reinforce your learning. I am going to open up this link here that takes us to this Microsoft Learn website, and Microsoft has done this really good job, I'd say in the last 5-10 years, of kind of expanding this content. They did not used to do so well with like sharing learning materials with the public in the past, but I don't know, like they must have turned a corner on it and decided to kind of put a lot of stuff out there. I know the first night we got together, we kind of looked at some of the stuff that's out there, but they have significant stuff on C#. Why? Well, answer is C# is Microsoft's version of the basically C++ programming language. And it's really, truly a variant of their original language called Visual Basic, right? And I should really correct that. It's not really a variant, right? So the C programming language, which has been around since late 60s, early 70s, eventually became C++. And then it kind of branched. Java grew out of it. A bunch of other languages did. Apple uses a version of C to code its operating systems called Objective-C. And now they've got a new language called Swift, which sits on top of it. Very cool language to learn, by the way, if you're into Apple products and iOS and all that, especially for mobile development. But Microsoft was developing its original operating systems, including DOS, right, command line, using BASIC, right, which was a different language altogether. That eventually became Visual Basic when they created the Windows operating system, which was visual, right? So they had a visual version of BASIC, which could basically create windows and buttons and checkboxes and sliders and things. And then somewhere in the mid 2000s, Microsoft made a decision, and I don't know if it was during the XP era or the Vista era, somewhere around there, that they were going to change their official language over to C#. Now, the interesting thing about it is a custom version of C, but it shares some aspects of Visual Basic, namely some of the language, let's call it libraries and tools that they've been using all along, that allows you to build very easily graphical applications for Windows, right? We're not at that point yet. But learning how to do GUI programming for Windows is not really that hard. Once you have all the basic concepts in place, then all of a sudden you can use Visual Studio is the tool to use for that, by the way. You just drag a window onto the screen, grab some buttons, throw in a text box, whatever things you want to put on your windowed application. And then you write code so that when you interact with that thing, it does something, right? So for whatever reason, they came up with the C# language. And then basically since the early mid 2000s, it's been kind of evolving in prominence. And just for example, when we used to teach intro to programming 20 years ago, we would teach Visual Basic on a Windows platform, right? Not C#. And then it full force changed in the 2010s, basically, to C#. And now there's kind of no looking back, basically. Visual Basic is still around and still used for some things, mostly legacy work or doing like macros inside of like Word or Excel. It's still utilized there. But I'll just put it like this. If you know Visual Basic, learning C# is not that hard. And if you know any other C style language, learning C# is not that hard because they're kind of basically all variants of each other. All of them have the parent language of the original C language. And the C language, the reason that one's important is that's our operating system development language, right? Unix, Linux, now Windows, any operating system you can pretty much think of was coded with C at its foundation, because C has the capability of working with machine level code where a lot of other languages don't. C# is super important for Microsoft. And since it's a custom version of a language, right, they have all the information on it. So the fact that they're now sharing it in this like learning repository is super cool. It really is. It's very helpful because they know more about their own language than other people do. So like when they're teaching you stuff, you're getting it from the source, so I do think this is a really valuable website. So when we do like, kind of point you out here to check stuff out, check it out, right? And then, by the way, feel free to explore and go deeper, right? You don't have to wait for me to tell you to like check this out on their website for you to check it out. If you're intrigued and you have the time, hey, go for it. It's free and it's for the taking. I do bring it to this particular page here because I have it linked up in module 2, and you'll notice that we're looking here at if statements and loops, right? And what they call conditional logic. And they have a whole tutorial with very nice little explanations, right? And if I kind of zoom in here a little bit, you will notice that they have little code examples. It doesn't look too much different than the stuff we were doing in our slideshow, right? And you can borrow these examples. So like you can come in here, copy the code. And I know last time I tried doing this, it didn't run. I have some suspicions as to why. Let me see if it runs this time. I'm waiting for the magic. Of course, since we last met, the Microsoft Azure cloud was having outages. Remember the week before AWS was having outages, and now Microsoft is having outages. What was the biggest service that was hit with Microsoft? Sam looks like you're about to say something. A lot of
Oh,
people are saying
I,
Microsoft Office,
what I
but
wanted
really,
to say is this probably isn't running because you're not using Microsoft Edge. They want you to use Edge for their
I think you're right. I think you're absolutely right that if I ran this in Edge, this would totally work.
top notch.
Yeah. All right. So I think this isn't going to run here, but I think you could move this over to Edge and it would run. But I think with the Microsoft Azure outage, the Microsoft Office Online was out for quite a lot of people. But what was really down tragically for a while was Minecraft. If you looked at Down Detector, that one was like peaking, and it's like, oh my god, nobody can play Minecraft. What a travesty. All right, so I'm thinking that's a correct assumption, and I really, frankly, never, ever, ever run Edge on my system unless Microsoft makes me launch it. So I do wonder if I run the same tutorial here, if it will load. So let's see if the theory holds there.
Mine isn't loading.
Yeah,
So that'd be quite amusing for for certain. Isn't Edge basically Google in the background these days anyway?
it is. It uses the Google Chrome, and technically it's called the Chromium code base because the
Yeah.
browser was originally launched in Linux environments first. And if you run a Linux distro, you don't download Chrome, you download Chromium, right? Safari, Edge, and Chrome all run the same code base. Firefox has its own. All right. Well, this is not loading. If you guys can get it to load, great. I just want you to remember the other thing that you can do is you can copy the code and bring it into Visual Studio. But they do a really nice job of explaining the stuff, right? Step by step. And then I think what's kind of interesting is how the discussion naturally leads to loops, because we haven't learned this material yet, but when you do loops, like, there's one type of loop called a while loop that also has true false statements in it, just like if statements do. So like this true false thing that we're learning is relevant to that concept as well. So that was one of the things I did want to kind of point out. But the grander goal was really to show you that the reference materials are here, and please take advantage of them. Run in the browser doesn't seem to be working, and I don't know if it's due to their outage or not, but who knows. The other thing I'm going to do is I'm going to jump over here and I'm going to do all my little investigations here on the Brave browser. We did talk about operators before. We talked about all the math operators. We talked about the assignment operator, which is just the equal sign. You guys recall all that, right? And how this one's not a math operator and not a logical operator. It is literally to assign variables. And then we got into the comparison operators, which were relevant to our conversation last week. So often we're checking statements to be true or false. And they have examples, right, of, equivalency, not equivalent, greater than, less than, greater than or equal, or less than or equal, right? You guys remember all that. I do want to kind of refresh your memory here that this site's also very useful. I do know that their little try it tools actually work. So if you want to play with code without coding it, you can come in here, right? And I know we've done this already. And you can just like change your code, for example. And actually, in this case, if I want to flip it to true, I have to set them both to the same. And that this should run in the browser. Okay, so their site works pretty well that way. The other types of operators we looked at are the logical operators, right? And, or, and not. Okay, and this is one where I always kind of stress this, and not because Python's the preferred language. It is because a lot of us here at school learn it, and maybe you've already learned that language prior to coming here. And in that language, we don't use these symbols, right? We actually say the words or and. But most languages, and I think of C style languages, and that would include C, C sharp, Objective C, Java, JavaScript, all those styles of languages do use these operators: a double ampersand for and, a double pipe for or, and then an exclamation for not, right? And I think I gave you pretty good tips on all of these. And remember that with ands, both statements have to be true for it to be true. You guys recall that? Yep. And here's the other thing about ands. The statement doesn't have to stop there. I can say if x is less than 5 and x is less than 10 and y is greater than 20 and z is 45, or I can have 20 of them in a row if my brain can process it. And if I do have, let's say, 20 statements like that, every single one has to be true for the statement to be true. Right? And that's pretty critical. Most of the times, if I'm seeing compound statements, they go maybe 2 or 3 levels deep, because what happens beyond that is most people's brains can't process the logic, real frankly. The computer can, but our brains can't. So if you think about like some of the examples we did last time, where like we did one if statement and then inside of it we did another if statement, and then we're like, well, but wait, that's kind of leading us to the same place. So we can just say, if this is true and that's true, then we can just get there, right? So can you imagine if you're adding a third level to that or a fourth level to that? It does get a little complicated. Ors, on the other hand, only one of the statements has to be true. And yes, it's most common to just have 2 statements, but that one also can extend beyond. So you can say, if this is whatever, or this is whatever, or this is whatever, or this is whatever, only one of them has to be true. Only one, even if you have 10 statements, to make the whole statement true. The thing that they don't really kind of mention in a lot of these logical operators is you can also do combination statements where you have one statement and you put it inside of parentheses that might have all of this, right, as an and inside parentheses, and then you can put an or next to it and throw something else into it and combine ands and ors. That's a possibility too. Once again, I think most people's brains don't think that way, right? It's not how they think through a problem, so they don't usually concoct statements like that. Usually that's a high level programmer kind of task, or you're working with an AI and the AI suggested you do it so you can write one statement instead of 5. That's the other way you get there. The not statement, of course, is one that's kind of tricky. And as we were kind of pointing out last time, like inside the parentheses here, there's an and. Both have to be true to be true. But then this means we're looking for whatever that evaluates to, we're going to flip it. So we're looking for the opposite of whatever that evaluation is. I'm not a huge fan of using the knots if I don't have to, because they do get very confusing, kind of like double negatives in language and nobody pays attention to them. Like I didn't do nothing, which implies I did something, right? You're not even sure about it as I say it. You're thinking about it, right? And that's exactly, you know, the kind of double talk that happens in your brain when you're kind of rationing through this stuff. So I like to reinforce those things because I do think that they're really easy to forget as we're learning this stuff. And remember, whenever we're evaluating those statements, we are really looking at the concept of true and false. In the C# language, we do have a data type for this called Boolean. And so when we declare a variable, we use the bool thing if we want it as a variable. Otherwise, if it happens inside of a statement, like an and or an or an if statement or a while loop, like we just learned, things evaluate to true and false. And that's the trigger for which pathway we're following. Do I have enough money to order pizza? Or am I making mac and cheese, right? Remember that example. And Boolean values kind of drive that. It is possible to set up Boolean variables. It's not unusual. And often when we create Boolean variables, we often form them, the names of them, in the form of a question, right? So notice, like, is C# fun? True. Of course it is, right? Because you're here learning it. So why would we make it boring? Is fish tasty? Well, I think that's true, but here it's set to false. So that's a really common technique. So in other words, like the naming of the variable in the form of a question, which asks basically a true false or a yes no, right? Implies that it's a Boolean just from the naming. But you can use that in your code, and it's excuse me, helpful for sure. All right. Next topic I wanted to hit here was just to kind of quickly review the if else stuff, right? And we started basically with an if statement, and often when we're checking an if statement, we're usually doing some sort of a comparison, right, to trigger a true false reaction so that we can decide to run the code or not. So here's where the logical operators and comparison operators all come into play. We have basically 3 different forms we've learned so far. So we've learned if, we learned else, and else if, right? And how to combine all those, even to nest them inside of each other or do combination statements to avoid that. But there's one that we didn't focus on, which is the switch statement. So that's going to be the new thing that we're throwing into the mix tonight. Let's just do a quick review of the basic ones, though. With an if statement, we're basically using the keyword if. We get some sort of an expression that we're testing inside a set of parentheses, followed by curly brackets, and then whatever statements we operate if that thing I highlighted evaluates to true. If it doesn't evaluate to true, we don't execute the code. Remember also that if you only have one statement inside of it, you don't need the curly brackets, right? And then I always caution people, well, what if you decide later you want to add another statement? Are you going to remember to put the curly brackets in? So I always say just put the curly brackets in if you can. I like this format for C#. It just kind of does it automatically anyhow, so probably stick with it. We can also get to the else, right? Same approach, right? So like if this statement up here is true, that code will execute. If it's not true, the else gives us a different pathway where we might execute some different code. So sometimes that's necessary, right? Just because I don't have money for pizza doesn't mean I'm not going to eat, right? Because, okay, maybe I can't afford pizza delivered, but maybe I can walk up to McDonald's and get a burger instead, right? Because I don't have, that type of thing, right? So different pathway. So if this doesn't trigger true, we have an alternate pathway. So that's if else. Sometimes it's necessary to check multiple conditions. So we did this too, right? And we played with that and like some of the nuances that happened with that. Remember, we did like the temperature thing, and the order in which we did it kind of made a difference too, right? In the order in which we checked it, that was kind of tricky. Um, but the only way sometimes to figure it out is to go through the manual process of doing it and struggling with it and going, oh, it's not working. Why? And then you got to think about it and then you figure it out, right? But this allows us to check multiple conditions, and that's not unusual, right? Because maybe if I don't have enough, maybe this is, do I have enough money for pizza? And let's say I don't have enough money for pizza, but maybe I have enough money for McDonald's. And then if I don't even have enough money for McDonald's, then I'm making mac and cheese, right? And that could be three different things. The else, of course, will always happen if the other conditions don't hit. Do you have to have an else if you have an else if? No. And ifs don't have to have else's. Sometimes you just have an if to have an if, and it doesn't have to have an alternate pathway. And that's important too. All right. There is a shorthand way to do this too. And this is, I think, going to come up in a future lecture. This technique is now available in a lot of languages, including Python, by the way. And they have what we call a ternary operator approach to writing an if statement. And I'm going to show you. For example, if I had this if statement, right? You can see basic if statement with an if and an else, right? I'm checking one thing, and then on each branch, right, meaning each possibility, I have one thing that might happen, right? I'm either writing one message or the other. The result is either true or false, and I got two possible options. It can be rewritten as follows. And I want you to look at this, right? This is an if statement. So it's the question mark and the colon. This is what we're testing for true false. Notice there's no keyword if here. We're just putting in an expression. If this evaluates to true, we do this. If it evaluates to false, we do that. Now, in this example, they're not putting in console write line. They could, by the way, they could put it right in those spots. They're instead realizing that it's going to yield a result. So if it's true, this is what it's going to grab. This is what it's going to do. And it's going to store it here in the string variable. Otherwise, it'll store this, and then we're putting it on the screen. But the fact is, right, like this true false, whatever this resolves to, could trigger, I don't know, a mathematical equation or a call to a function. We haven't learned about those yet, but it could trigger different courses of action. And notice it's just one line, right? Super, super efficient. Not super heavily used by a lot of people for whatever reason, but I am starting to see a lot of younger programmers that are in the field that are starting to like leverage this, because now instead of like writing like 3 lines of code or 6 lines with semicolons and curly brackets, I'm getting it like on one line. I mean, that's a lot more efficient to look at, right?
Hey,
Um,
Takis,
yes.
if uh if you were to put the console write line right in that line, then would you not use the string? You would just do
Exactly.
result equals.
Yeah, correct. And I think we can verify it here. Um, yeah, in fact, let's see, how would we verify that? We would just simply, let's just move this down. And actually, I don't want the semicolon. And actually, we would have to engineer it a little bit. Let's be clever about it. Build the statements first. have a couple superfluous ones there, but really that's the whole statement. See if this runs. Hopefully it doesn't throw an error on me. Yeah. Okay. So apparently it does only assignment, call, increment, decrement. Oh, wait. Okay. So what this is telling me is I do need to have a place to place the result. So this one won't trigger a console write line. So apparently we do need to store it. Okay. So this is where it's different. All right. So I eat my words on that, right? But in Python, that would work, right? What I did would work in Python, but it doesn't work in C#. Right? This is one of the problems about bouncing between languages. But you know, Caleb, thank you for forcing me to try it, because now you're answering the question in my head. So next time I encounter it, hopefully I won't shoot myself in the foot like that again. So, all right, let's move on now to switch statements. And I always think of these as switch case, by the way. And this is a really common technique to use to replace a complicated if else if statement that's got a lot of different conditions to check. All right, think about a scenario like this. You're writing an application that interacts with a user, and maybe the user is filling out a form that includes their name, their address, their phone number, whatever. And part of their address, right, is like, okay, put in your zip code, put in your state, and then let's say you're calculating sales tax or something weird like that. Depending on what state they choose, you might have to calculate a different sales tax rate. And then you might have to write an if statement like, if state equals Wisconsin, sales tax is whatever. If state equals, or else if state is Illinois, et cetera, et cetera. Can you imagine the complication of like writing all that, right? So what a switch statement does, it allows you to capture a value somehow. And then once you have the value captured, like maybe it's a 2-letter thing for a state abbreviation, you throw that into a switch statement. This is not a true false. This is just a piece of information here. So it's a different approach. Then that piece of information is checked against each one of the possible cases. And it operates like this. It looks at the first one and goes, does it match this one? Nope. Does it match that one? Nope. Does it match that one? Nope. Does it match this one? Yes. Right line, break, pulls you out of the switch statement. Very important on these. If I don't have a break statement there, it'll keep processing through the other statements. Weird, right? So the break statement is critical to include to get you out of there. I have seen people omit it on purpose for functional reasons, but this is a really common thing. Let's just run this really quick and I'll show you. Let's change the day to, I don't know, 6 and run it. And of course that would match Saturday if it runs. There we go. Right. So case is 6 and it's Saturday. And once again, not true false. It's just receiving information. But in principle, we're still making a selection as to what code we're running. So that's why it's comparable to an if statement. But in some ways, this is a little bit more efficient, you know. And once again, think about the scenario if I was writing that code that I was talking about for sales tax by state, you know. And then if you want to even make it more complicated, you could have additional if else statements for counties, right? Because not only the states have their own sales tax, but counties have their own sales tax. Right. So
then if you had, let's just say the 50 states, would you have to case all those 50 states then like that?
Yes.
Okay.
But here's kind of one of the clever things about it. If, let's say I had 3 states that had the same sales tax, I could set up case 4, 5, 6, or like, I don't know, pick 3 states that have the same sales tax, and they could all be in one statement.
Oh.
So there's some efficiencies there that you wouldn't get otherwise. It does, I don't know if you're catching on this either, but it does also eliminate all the curly bracket stuff that you do with if statements. Right. So because it's a little bit different format, there's some variants to this, right? So I talk about the break keyword, that being important. You can also throw in a default action so that if none of the cases hit, it's kind of like if you go if, else if, else if, else if, else. This would be kind of like an else. So this would happen if none of the other cases catch, or if a person forgets to put in a break statement, it would catch also. So this is kind of useful in a way. So like in the example I was using above where we put in all the days, what if somebody typed in 8? There's not 8 days a week, only in Beatles songs, right? And then, the default would catch in that scenario. All right. So what I'd like to do as an example, and I'm going to include this as really part of the lecture, so I'm not going to publish this as a separate like assignment solution, is I want to look at our lab assignment and re-engineer it to use a switch statement. Remember the one where we converted like teaspoons and cups and quarts and all that stuff? Remember that program? So I'm going to go ahead and bring up Visual Studio here, and I'm going to do a new project. And was that module 2 lab, and I'll call it alt, or maybe I'll call it switch. Name it what it is. So I'll do that. And if you guys want to code along with this, that's fine, just to practice, or if you just want to watch, that's fine too. I do think this is a useful technique to use. I kind of have some general rules of thumb about like when I use it. Like if I'm doing an if, else if, and I get to the point where I have like 4, 5, 6 else ifs, then I start thinking, should I do this with a case? Yeah, it's about that point where I start thinking about it. But if I was doing a list of states, oh my God, I would just immediately go to switch. That's just me and how my brain thinks. All right, I am doing this in a quick copy paste fashion. I first am going to declare a bunch of variables. All right, so this is not exactly our solution from last time. I am going to prompt the user to enter in an amount in milliliters. We're going to capture it, turn it into a double. Then we're going to throw our menu on the screen. You guys remember how I did the menu last time? I just kind of did console write lines, but here I'm doing it all in one line. That's my whole menu. Notice the new line escape sequences. So it's going to be 4 lines, teaspoons, whatever. And then we're still going to be looking for the user to make a selection. So I'll give them the prompt. Let me know if I'm going too fast. I know I'm kind of moving quick, but we have done this work. I'm just doing a slightly different version of it. All right. Now comes the switch statement. And what I'm going to do here is I'm going to kind of build the outer shell of it and add the content one at a time. So first we'll check the switch statement. We're going to have some criteria to check, and then I'm going to have my curly brackets. And what am I going to be checking? Well, they're going to get a menu, right? And then the menu, they're going to type 1, 2, 3, or 4, hopefully, that they type the right numbers. And then that will trigger the conversion that they're looking for. It's kind of what we did before, but last time we did it with if, else, if, right? So here, I'm going to be looking for whatever option they typed from the menu. So, they chose the menu option. We captured it here in a thing called option. So option is the information I'm checking. It is not a true false statement. It's just information. What kind of information is it? It's an integer, it's a number. So I don't have to put quotes around anything. When I get inside here, I'm going to have case. It's saying case 0. I'm not going to have a case 0, but I'm going to have a case 1. And then we're going to do our conversion. Right, so here's the conversion. Then we're going to put a message on the screen showing them the output. And then we're going to break to get out of the statement. Otherwise, it will keep processing. And then basically what we do is we just carry on, and I'm just going to copy paste a bunch of stuff in here, by the way, so don't freak out. Don't freak out that I'm going too fast because it's intentional. And I'm trying to get it in the right spot there. There we go. So then I have a case 2 where they convert to tablespoons, 3 is cups, 4 is quarts. And I decided, well, what happens if they type, you guys remember, what if they type the number 5? Because that's not a menu choice, right? Well, in that case, I will have a default. Oops. Apparently I didn't copy it. Highlighted it, but didn't copy. I'll have a default. And if they type a wrong number, I'm just going to say invalid input. We don't have a loop structure in place yet where we can keep the stuff running to give them another chance. It's just going to fail. All right. Let me run the code. I'll show you it still works. Right. So we'll see some console output here in just a moment. All right. And what was the number we're using? 75. And then let's do cups. And there you go. It's doing the calculation. That's just using a switch case, right? And once again, it's an alternative to using a sequence of if, else, if statements, right? Most of the major languages have a structure like this. So if you went to Java, they have a switch case. If you go to regular C, they have a switch case. If you go to JavaScript, they have a switch case. You go to Python, they don't. In Python, they have something called match case. And strangely enough, it's kind of a brand new feature. It just came out like 2 years ago. Prior to that, they didn't have it. And I was like, what? They don't have a switch case in Python? Yeah. And then somebody's like, all right, let's just add it. Everybody's complaining that we don't have it. So let's just put it in there. So Python has one too, called match case. But this is really useful. And once again, when you have like a lot of stuff you have to go through and process, this is the go-to. With this a number of choices, else if is fine. But if I had 50 choices to go through, switch is definitely the tool. Just less likely to make mistakes, mostly because of the curly brackets, by the way. All right. Any questions on this one? You guys good? All right. Here's what we're going to do. We're going to take a break. And I think I'm going to stop the recording here. And when we come back, we will work through the assignment together. Right. And we have plenty of time to go through it so we can really focus in on it and do some good work on it. All right, folks, this video will end here, and I'll see you guys in about 5 minutes or so.